start. So my name is Jhin. So today I'm going to talk about how to build full stack application only with Dart. So Flutter and then also backend is going to be Dart. So a little bit of introducing myself. So I'm full stack developer at Unity. I know what you want to say, but keep it. And I'm GDG and the FlutterMTL organizer. And I have some experience with the Android and embedded system. And then I'm also Scrum Master. So if you want to know more, the LinkedIn link. But once you have it, my slide, you can try to connect with me. All right. So today I'm going to talk about why we need to build full stack in Dart. And what are you going to build? I'm going to show you. And then little global architecture, project structure, and the REST API. And I'm going to show you mostly the code, actually. So it's going to be actually easy. So I don't go too deeper, just easy enough to make one application. So why full stack in Dart? So you can use one single programming language to make backend and frontend. That must be the biggest benefit. And then it means you can also share code between front and backend. So let's say you make one data model, then you can use it without code generation. I know, I actually like it, but you can just use single code that's used in frontend and backend. And obviously Flutter, since I know maybe some of you is not Flutter developer, but let's assume we already know Flutter development, then you just need to learn one framework with the same language, then you're going to have the backend knowledge. And based on my experience, it was really easy and fun. I like the Reader platform. I put it here, Dart Frog. So this is the backend web framework. Make it your life really easy to make the backend app. And performance, yeah, I put little question mark. Actually, I only put question mark because I didn't run benchmark myself. I read through internet, someone did it. Apparently, for simple CRUD application, it performs really well. It's really fast. But if you want to do like memory intensive application, it might go slower because of the logic. But if you want to go production level application, I think it's up to you to run benchmark and then make sure the performance is fit to your product. All right, so what we're going to build today is this. On the left side is the backend. On the right side is the Flutter application. So just simple, you just add entry, and then you call the REST API in backend, and then you just save that data in the backend. So frontend doesn't have any data. Right? So global architecture, as I already told you, frontend is going to be in Flutter. Backend is going to be Dart Frog, the web framework I'm going to introduce today. And then short code is going to be written in pure Dart. So no Flutter, no Dart Frog. And then there's a little drawing. So like you see there, to-do entity is it like, you can see of this as data model. So to-do data model, I'm going to share between backend and frontend. And then I also have the interface for the to-do repository. I'm going to implement this interface in the backend and frontend. And then you can see that here, the remote to-do repository. This one is actually REST, the API client. And then backend is going to have the REST API handler. And then this one is going to save the data in memory. So I don't use database just to make it simple. But if you want to use database, you can implement your database to the repository instead of in-memory repository. Right, so project structure. Also simple. You can see that packages folder have front-end Flutter folder, and the backend same thing, backend Frog. And then the short library name is going to be just to-do. So that one has the data model and the repository interface, and Flutter part, Flutter UI, and the REST API client. And the backend is just to the REST API server. And these are all REST APIs that I implemented. So /to-do-s will give you the list when you call as a get. And then if you want to add new entry, you're going to put the you pass the to-do in JSON to post it. And then if you want to get specific to-do, you're going to put the ID of the to-do with the get. Then we give you the exact to-do. And then if you want to update it, for example, if you want to just check it, then you just call the put API so that you can update the to-do item with the ID already have. And then we can delete by ID as well. So that's it. And then I'm going to show you some code. So those are something I used to make my application. Malus, I used it just to make monorepo project so that I can put the all different project in the repository. And then Dartfrog, I already told you, it's a backend web framework. And the Riverpath, I used it in front the Flutter application, just put little state management. But I didn't explain too much for that, don't worry. And then I use Flutter, obviously. And then I will show you how to deploy in Docker as well. That's another benefit of using Dartfrog. So yeah, actually I'm going to go to the code. What do we have? All right. So is it big enough for you guys? Or maybe I can make it a little bigger, like that. Yeah. So in the remote to-do project folder, I have packages. So I'm going to show you what's inside. So like I told you, there's 3 folders, one library, backend, and frontend. That's it. So if you open it up in VS Code, it's going to be looking like that. So backend, frontend, and shared code. Actually, I'm going to show you how I make it run. So one thing good stuff with the Dartfrog, they also have integration with the VS Code. So I can just do this to start the application. Yeah, don't worry about this. Then I'm going to open the app. Running the Flutter app for macOS, so native application. Oh, no, actually it's a browser. It works for both, actually. So yeah, we can start with the browser. We already did the web Flutter, so let's do it. Okay, and then I'm gonna show you here. Do you see a little log here? So to-dos endpoint is already called, and then it returned 200 with the empty list, actually. So when I add test one, so he posted one to-do, and then it gets all the list, actually. So every time when I add new entry, I am getting whole list. Of course, it's not optimized, but this is what I'm doing here. And then if you want to do like check, and you see put endpoint is called, and then it returned the 200 as well, so that I was able to update the list as well. All right, let's see now the code. I'm going to start from the shared application, shared library. So like I already told you, there's the 2 parts. One is data model, which is to do. It has ID, title, and then it's done or not. And then little business logic like toggle done, then it will change the data, it's done, and then you return the new instance to keep the immutability. And the copy with is just util function so that you can copy some instance. I mean, create new instance with new data. Okay. And this is a repository interface that I told you. So it has the fetch all and the API, and then get by ID, add, delete by ID, and update. And that's it. Actually, that's the all for the library part. And I'm going to show you also how I used it. In the backend, I have in-memory to-do repository. So I implemented this interface in backend so that I can have exactly same method. And then same thing, it does do it. And then I have to-do list in memory, like I told you. You can replace it with a database, but for now, it's a sample application. I use the memory. So he's saving everything in this memory, and then he reads everything from this memory. And backend application has route. So who knows about Next.js? So Next.js is using directory-based the routing. So Dartflow is similar. So route here, the root path is the slash, and then you have to-do folder, so slash to-dos, and then you have ID. So this is going to be the endpoint with ID, and then just index is going to be the root path, so that the to-do list or when you post your to-do, it will use here. And so yeah, let's start from here. So let's say if you call the get endpoint in to-dos, this will come to here, the handler, and then I have a little switch so that I can determine which method is used. So first one is get, second one is post. When it's get, it goes to here, and then it will just read from the repository and then return it. And same thing for the post. When I receive it, I just decode the JSON and then make it as data model, to-do data model, and then using the repository, I add it. And something interesting here is about the Dartflow. They have kind of dependency injection. So they call it provider. So in the middleware, I can add repository in it, meaning that in this passive context, I can access it, right? So here, what I did is I'm reading the to-do repository from the context, and then I'm just calling it. So I don't need to worry about, dependency injection and so on in this architecture, right? And yeah, that's actually all. And then this one is about the course, because if I use the running web application from the browser, there's always issue with the cross origin. So I just want to bypass for this example. So I put this one. So middleware is also working in the directory-based level. So I put here, meaning that it's from the root, meaning that every path is going to be applicable using this middleware. And then this middleware is under the to-dos folder, meaning that it's going to be only applicable under to-dos, the path, right? So that's it. That's the back end. And then I'll show you a little bit of front end. So let's see. I have only one page. So page have the two components. Okay, let me open the application. First part is the text field, and then next part is the list of the to-do. So first part, let's see, to-do text field. It's actually only this, nothing more than that. So same thing. I'm calling the add function in the repository so that I can add new to-do, meaning that here I type something, and then when I enter, it goes to the onSubmit, right? And then it will call the API to add it, and then repository will call the REST API to send it to the backend, right? And list is the same thing. You just read list from the river path provider, and then I can also call the toggle done function in the repository so that I can change the status. So let me also show you how the repository looks like. So I hard coded the localhost 8080, and then this is remote to the repository, calling just, let's say for the add function, it's calling host endpoint of to-dos. And then same thing, delete, it's gonna call delete. And then fetch all, it's gonna call get, and so on, that's it. So once you call API to the repository, you will call the client, the REST API call to the backend, and backend will receive it and then make it as to-do data, and then he will store it or remove it or whatever he needs to do. And yeah, for some people may interested in RiverPod, the state management. So I have used RiverPod code generation to make the provider, and then I use the RiverPod for the dependency injection. So it's a little bit similar to Dartflow dependency injection I introduced. So it's provider, same thing. You can put this in the RiverPod provider, and then you can read it. So that's what I do here. So I read RiverPod, the to-do repository provider from the RiverPod. I defined actually here, and then calling the functions of the repository. So it just make it simple, but you can replace it with any other the state management system you like. So this is just really simple architecture. And what I also liked about it is that you can also debug it. Okay. So of course, we can do the breakpoint, everything for the Flutter app, but backend app is same thing. So let's say you want to debug route or get list. I put a breakpoint, and then I'm gonna call. Then it stop here, and then I can inspect some data here. Okay. I can hover it, and then I can see that what's the data in it. So it's actually really easy to use it, and then you don't need to really think too much to learn this new framework. So that's what I really liked it. And furthermore, okay, I'm gonna stop it, the backend. What I'm going to do, I'm gonna try to build. So once I build, it will make the native application like Golang or like C or whatever the native application. He will build it, and then he also give you the default Docker file. I don't know if you see it, but meaning that I can just Docker build with it. Then you're gonna have already backend container so that you can deploy into any of your container the solution, Kubernetes or Cloud Run or just Docker and anything. So I'm gonna run it. On my local container, and since it's the same address with the same port, I think I should be able to do that. So let's say all the data here is going to remove because it was from my local machine. Now it's in Docker, which doesn't have any list. So just to refresh it, I'm going to add new data. So he read again the list from the new server. So now you see the different thing. And then you see, I don't know. This is not the proper way of benchmarking, but it's super fast. And then the need to do it, and then the first run is also fast. So let's say I'm gonna kill it. I kill the Docker container. I'm gonna restart Docker container. let's see. So did you see, I mean, the time, how it start, I mean, how fast it start the application? Of course, if you have heavier application, it might be slower, but thanks to the native compilation, you don't have virtual machine in it. So it start the server right away. So yeah, actually, that's it. Maybe I can show you just one more thing. It's not important, but yeah, I can run it. In macOS. Yeah, usually it takes some time to build for the native platform. It started as new instance, but the data is already in the backend Docker container. So he loaded every data I already added in there. So yeah, I can still do that. And this is native application. And then the other example I show you was the web application. And exact same code is running in different platforms. That's about it, what I prepared today. And, oh, not this one. So I have some references. So first one is the article that I wrote about it. So if you want to see a little more detail of it, I will later when I share this slide, you can go there and then check it out. And Dartfrog website, and then Melos website. I didn't showcase for the Melos today, but this is the quite useful tool to manage the monorepo project. Maybe later I can do another talk about it for more detail. And then Riverpod, I gave you a little intro, but the same thing you can learn from the official website. That's it. Anyone have any question?
For the presentation you showed the code, I see you have two documents finding the same, but I don't know how it works. Can you go to your code?
Okay, just a second. So I'll open it up here. So which one?
I think it's middleware.
Oh, okay.
There were two same thing. I don't know how it works.
In the backend, in route,
Yeah.
you are talking about this one and this one, right?
Yeah.
So this middleware is applicable for all paths from the root. And then this one is only applicable for to the path. That's it. You want it?
Are there essential packages
Essential package for backend? I would say it's only Dartfrog. They also have test framework altogether with the Mockito and so on. I don't know if Mocktail or Mockito, I don't remember. So you don't even need to add any other dependency. Of course, if you want to use database connection, you may need to have another package depending on your needs. But yeah, there's also Dart like. Yeah, it's lacking compared to JavaScript or Python, obviously, but there are options. They also have like ORM, the packages, so that you can data modeling with the database connection, MariaDB, MySQL, or MongoDB. All the essential packages are there, but if your database system is a little. REST API? That's a Dartfrog itself. Yes, you can do that. And then you can even serve the static files with it if you want. Oh, I didn't dig into it actually, honestly. But Dart, you can easily add .env or whatever environment variable. So
yeah, but I mean the system.
yeah, yeah. I don't have anything to show you right now, but yeah, I'm pretty sure that's basic. I don't know. I think we have time, so maybe I can show you their website actually. I think this one. we can briefly go through what they have. So in the basic, they have route, middleware, dependency injection, serving static file, and then you have environment. So this is your question. And yeah, I mean, their documentation maybe lacking little of detail, but I think it's good enough to read it through. I mean, as a beginner, I think it's really well documented, I would say. But if you are really advanced technique, then maybe you need to dig into their source code or something. Dartfrog is based on the Shelf, actually. Shelf is another framework, so they made it just, I think they wrote somewhere, yeah, the tap into, yeah, with the Shelf, and then the thing. This is the basic web server middleware for Dart. I think, yeah, I think I read about it, but it's based on that something. And then, yeah, there's a few alternatives. Yeah, Sourpod is another alternative, yes. I didn't try Sourpod actually, so, but it looked actually promising. I only saw the YouTube video, but that looked good actually. And the last meetup, Boris present about the Cloud Run with the Dart function. So maybe you can use that way if you don't need complete web server, but you want to serve function with it.
Have you seen some benchmark for performance?
Yeah, good question. But I don't have it, honestly. But I just searched it a little bit. But like I already told you, it looked promising for the basic function. Like if you want to just do database CRUD-based application, I don't think it's going to be a bottleneck. But if you need heavy business logic application on the backend side, that could be a trouble. But you need to run it yourself.
Is Dart, in the past it was using the Dart VM, is it running a compiled version now?
Yeah, that's exactly the same thing. So when I run it from my local machine, it was running in the VM so that I can do the debug, so JIT base. And then the other one was the compiled version when I showcase in the Docker. So that it was super fast. I just Docker run and then it's already ready, right?
Because it doesn't read the code, already compiled, already has a message, we can like, you have something good at the time. So you already have complete.
Yeah, I think that's true or false actually. So, native compile doesn't mean it's always better. For example, if you run Java, I know many of them, including me, hate Java. But once it started and running, the performance is actually not bad. But starting time, it's going to be painful. Anyone? Then thank you very much. All right.